Hello students, this is your economics coach Prateek Bhasin starting a new chapter. Today we will be discussing about chapter 6 from your book Statistics for class 11th. Today's chapter is measures of dispersion. Now what is dispersion? So dispersion actually measures the distribution of a series from a central value, may it be mean, median, etc. In this video, we will be discussing about 4 measures of dispersion, that is range, quartile deviation, standard deviation and mean deviation. So basically, what are the qualities of a good dispersion? So these are, the first one being, it should be representative of all the items in the series. This means that a measure of dispersion should actually include all the items of the series. Similarly, we have it should be easy to understand and easy to calculate. Then we have it should be capable of some further treatment that could be used in some further analysis or interpretations. Then we have that it should not be affected by the extreme values of the data. That is, it should not be dependent only on the extreme values of the data. So now we have 2 measures of dispersion. The first one is absolute measure. The next is relative measure. So what is the basic difference between absolute and relative measure of dispersion? So in absolute measure of dispersion, this represents the data in the form of the unit in which the data is presented. So absolute measure of dispersion actually represents the value in terms of the values of the original data. But in relative measure of dispersion, the value is presented in terms of a ratio or percentage. So if the data is of the weight of the students, that is in kilograms, so the answer to the absolute measure of dispersion will also be in kilograms. But the answer to the relative measure will be in ratios or percentages. Then we have under absolute measure, we cannot use it to make comparisons, but in relative measure of dispersion, the values can be used to make comparisons. The fourth point deals with what are the absolute measures of dispersion. These are mean deviation, quartile deviation, range and standard deviation. And the relative measures of dispersion is calculated by calculating the coefficient of range, coefficient of quartile deviation, coefficient of mean deviation and coefficient of standard deviation. So let us start with the first measure of dispersion, that is range. This is the simplest measure of calculating a measure of dispersion. So it is basically the difference between the highest and lowest values of the data. So its formula is highest minus lowest. So we also have the coefficient of range, which is represented by the formula highest minus lowest upon highest plus lowest, or highest minus lowest upon highest plus lowest into 100. We have some merits and demerits of the range. The first merit for range is it is very easy to understand and easy to calculate. So you can very easily calculate and understand what is range, because it is basically the difference between highest and lowest. The second merit is it gives the broader picture of the data at a glance. So if you look at the value of the range, you will get to know what is the difference between the highest and lowest values of the data. It will actually provide you the picture that how dispersed the data is. Then we have the third merit, which is it is the quickest measure of dispersion. So if you want to quickly calculate a measure of dispersion, it is range which you should go for. Now let us understand what are the demerits of range. So the first and the foremost demerit of range is that it is actually affected by the extreme values of the data, because it is only the difference between the highest and the lowest values. The second point is it can't be calculated for an open-ended series. So sometimes we have a series which does not have a highest value because it is an open-ended series. So the range value cannot be calculated for those types of data. Then the third demerit is it does not give an idea about the pattern of the distribution, as 2 series with the same range can have different variability. So if we have a series with range as 10,000, it does not mean that all the values of the data have the same variability. Now, let us suppose in a family the highest income is 1 lakh rupees and the lowest income is 90,000. So, the range is 10,000. Suppose in another family the income of the highest earning member is 50,000 and the income of the lowest earning member is 40,000. This does not mean that they have the same variability, although they have the same range. So, let us move ahead and practice some questions for range. So, we have this question for an individual series where I have the data. So, I have different values, that is 22, 35, 32, 45, 42, 38, 39. Let us locate the smallest value. So, the smallest value we have is 22. Now, let us locate the value which is the highest. So, we have 45. Now, let us calculate range. So, the range is highest minus lowest. So, it will be 45 minus 22. So, my answer is 23. Now, let us calculate coefficient of range. So, the formula for coefficient of range is highest minus lowest upon highest plus lowest into 100. So, we have 45 minus 22 upon 45 plus 22 into 100. This gives me 23 upon 67 into 100. So, let us divide 2300 with 67. So, we have thrice. So, this will be 201. So, 29, 290, then we have 4 times, this will be 268, the difference will be 22 point. So, let us make some space for this. So, 22 and when we subtract 201 from this we get 19, 190. So, let us leave it here. So, we have the answer as 34.32%. So, the coefficient of range is 34.32%. So, now let us move on to our next question, which is the question for a discrete series. So, we have the data of a shop which deals in shoes. So, we have the size of shoes and the number of shoes that are being sold for that respective size. So, we have nothing to do with this part because this is the frequency and we only have to calculate the range for this variable, that is the size of the shoes. So, we want to know that what is the range of the shoes that the shopkeeper keeps. So, the shopkeeper has the smallest size as 6 and the largest size as big as 13. So, let us find the range. So, we have the formula for range which is highest minus lowest, which will be 13 minus 6. This gives me 7. Now, let us find out the coefficient of range, which is depicted by the formula highest minus lowest upon highest plus lowest into 100. So, we have 13 minus 6 upon 13 plus 6 into 100. So, the final values will be 7 by 19 into 100. So, this will give me an answer with 36.84%. So, I have already calculated this value so as to save our time. So, the coefficient of range will be 36.84%. So, let us move ahead and calculate the coefficient of range and range for a continuous series. So, we have this question with us, that is the marks and the number of students. We are only concerned with this variable marks. We are not concerned with the frequency while calculating the range. So, the formula for range is highest minus lowest. Now, under continuous series there can be two types of range, one taken from the class intervals and the other taken from mid values. So, let us calculate both the ranges. So, the first range is highest minus lowest. So, we will take the highest value of the last class interval. So, the last class interval is 50 to 60. So, the highest value is 60. That means the upper limit of the last class interval, and we take the lower limit of the first class interval, that is 10. So, the range will be 50. If this range would have been calculated using the mid values, the value would have been, the mid value for the first class interval would have been 15. I got this by adding 10 and 20 and dividing them by 2, because the formula for mid value is lower limit plus upper limit divided by 2. Similarly, finding the mid value for the last class interval, it would fetch me a value, mid value is equal to 50 plus 60 divided by 2, this will be 55. So, I have two mid values, one being 55 and the other being 15. So, the value of the range derived from mid values would be 40. So, we have two ranges in continuous series, one taken from the class intervals and the other taken from mid values. So, I will be moving ahead with this values. Now, let us find out the coefficient of range. So, the formula for coefficient of range is highest minus lowest upon highest plus lowest into 100. So, we have the value 50 by 70 into 100. So, let us calculate the value, which comes to be as 71.42 percentage. So, this is my coefficient of range. Now, let us move forward to a new type of measure of dispersion, which is quartile deviation. You might be remembering when we studied the median, we also studied about quartiles. Quartiles are those values which divide the data into 4 parts. So, we studied about the first quartile and the third quartile. We know how to calculate the quartiles. Under this part, we will be discussing that how is quartile a measure of dispersion. So, we know that to calculate quartiles, we have the formulas for individual and discrete series and for continuous series as well. So, the formulas for measure of dispersions are Q3 minus Q1. This represents the interquartile range. This means the range between two quartiles. Then we have the semi-quartile range or quartile deviation. This is basically the average of the interquartile range, that is Q3 minus Q1 divided by 2. And finally, when we calculate the relative measure of dispersion for this quartile deviation, we get the coefficient of interquartile range. So, we have Q3 minus Q1 upon Q3 plus Q1 into 100. Let us move on to our questions. So, we have these questions with us. So, where we have to find the interquartile range, the semi-quartile range and also the coefficient of the quartile range. So, let us move ahead. So, we have these values 200, 210, 208, 160, 220, 250 and 300. Let us first arrange these values into ascending order. So, we have the smallest value as 160. So, the first value will be 160. Then the next value will be 200, the next being 208, 210, 220, 250 and last being 300. So, we have 1, 2, 3, 4, 5, 6 and 7 values. So, 1, 2, 3, 4, 5, 6, 7. Okay. Now, because this is an individual series, the formula for first quartile is n plus 1 by 4, third term. So, we have the number of terms as 7 plus 1 by 4th term. So, this will be our second term. So, our first quartile will be 200, that is the second term. Now, let us calculate the third quartile. So, this will be 3 n plus 1 by fourth term. So, this will be 3 7 plus 1 by fourth term, that is the sixth term. Now, let us locate the sixth term. So, third, fourth, fifth, sixth and seventh, which will be 250. So, the value for the third quartile is 250. Now, let us calculate the values of dispersion. So, we have the interquartile range, and the formula for interquartile range is Q3 minus Q1, that is basically the difference between the two quartiles. So, this will be 250 minus 200, and this would give me the answer as 50. Now, let us find out the semi-quartile range or the quartile deviation. So, the formula for this is Q3 minus Q1 divided by 2, that is 250 minus 200 divided by 2. This gives me the answer as 25. Now, let us find out the coefficient of quartile deviation. So, the formula to this is Q3 minus Q1 upon Q3 plus Q1 into 100. So, we have Q3 minus Q1 as 50 and Q3 plus Q1 as 450. How come this 450 arrived? This is 250 plus 200 into 100. So, we have 50 upon 450 into 100. So, let us divide it. So, I will get 100 upon 9. So, the value to this is 1 9 1 0 1 9.0. So, this will go on. So, the value will be 11.11%. So, this is the value of coefficient of quartile deviation. Let us move on to our next question, which is about discrete series. So, we have this series which relates to the marks and the number of students. So, let us first write the series in a vertical format. So, 2, 4, 6, 8, 10 and 12. Then let us represent the frequencies 3, 5, 10, 12, 6 and 4. Now, what are the cumulative frequencies? Let us first know that 3, 8, 18, 30, 36 and 40. So, now let us find out the first quartile and the third quartile. So, the formula for first quartile is n plus 1 by fourth term. This will be 40 plus 1 by fourth term, that is 10.25th term. Now, let us find out where does 10.25th term lies. It does not lie here, it does not lie here, but it will always lie in the cumulative frequency of 18, which gives me the quartile 1 value as 6. Let us find out the value of the third quartile. So, the formula to this is 3 n plus 1 by fourth term. So, this will be 3 n plus 1 by 4. So, this will be 30.75th term. Let us find out the location for the 30.75th term. It will not lie here, will not lie here, will not lie here. It also will not lie in 30 because it exceeds 30. So, it would always lie here, and the value of third quartile will be 10. So, now as I have the value of quartile 1 and quartile 3, I move on to calculation of the interquartile range, which is depicted by the formula Q3 minus Q1. So, this will be 10 minus 6, that is 4. Now, let us find out the value of semi-quartile range or quartile deviation. So, it is basically the average of the interquartile range. So, it will be 10 minus 6 by 2, that is 2. So, this will be 4 marks, this will be 2 marks, because absolute measure of dispersion are always presented in terms of the units of the data. Now, let us find out the coefficient of quartile deviation. So, the formula to this is Q3 minus Q1 upon Q3 plus Q1 into 100. So, we have 10 minus 6 upon 10 plus 6 into 100. So, we have 10 minus 6 as 4, 10 plus 6 as 16 by 100. So, when we divide this, we get the answer as 25%. So, this will be the value of coefficient of quartile deviation. Now, let us solve a question for continuous series. So, let us first write the question in a vertical format. So, we have 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25 and finally 25 to 30. Let us also represent the frequencies. We have 3, 9, 15, 23, 30 and 20. So, 3 cumulative frequency will be 12, then 27, 50, 80 and 100. Now, let us calculate the value of the first quartile. So, this will be n by 4th term. So, now we have 100 by 4, that is the 25th term. So, for 25th term we locate it and we get that it would lie in the class interval 10 to 15. So, quartile 1 would lie between 10 to 15. Now, let us calculate the value for the first quartile. To calculate the value of first quartile, we will have to use the formula L1 plus n by 4 minus CF of the previous class upon frequency of the present class into class gap, that is represented by H. So, we have 10 plus n by 4, that is 25, the previous cumulative frequency being 12 and the present frequency being 15 into the gap, which is 5. So, we have 10 plus 13 by 15 into 5. So, we have this as 10 plus 13 by 3. So, 13 by 3 would be 4.33 and this will be 10, giving me the answer 14.33. Quartile 3. So, quartile 3, the formula for quartile 3 is 3n by 4th term. This will be 3 into 100 by 4, that is the 75th term. Now, 75th term would lie in 80 cumulative frequency, giving me the class interval as 20 to 25. So, we have the class interval as 20 to 25. Now, let us move ahead and calculate the value of the third quartile. So, we have L1 plus 3n by 4 minus cumulative frequency of the previous class upon frequency of the present class into class gap. So, we have the lower limit as 20, this as 75. Let us look up to the cumulative frequency of the previous, which is 50 and the frequency as 30. So, we have 50 by 30 into the gap, which was 5. So, 20 plus 25 by 30 into 5. So, this will be 5 by 6. So, we have 20 plus 25 by 6. This would give me an answer. This will be 20, this will be 4.167. So, my final value will be 24.167. So, now let us move on to calculate the interquartile range. So, the value for the interquartile range would be as follows. So, it will be derived from the formula Q3 minus Q1, which will be 24.167 minus 14.33. So, this would give me a value of 9.84. Now, let us calculate the value of semi-quartile range or the average of the interquartile range. So, this will be 9.84 divided by 2. So, it will be 4.92. Now, let us calculate the coefficient of quartile deviation. So, it will be derived by the formula Q3 minus Q1 upon Q3 plus Q1 multiplied by 100. So, we have 9.84, that is the difference between two quartiles or the interquartile range. Then we have the addition of 24.167 and 14.33 into 100. So, this will be 9.84 upon 38.5 into 100. So, it will be 984 divided by 38.5. So, we will have the value as 25.55%. So, this will be the value of coefficient of quartile deviation. So, I hope you were able to understand this topic. I request you all to please refer to your text and practice some questions. I will see you in the next session. Till then, please stay safe and take care.